Hey there, today we'll be doing this question that appeared in Leetcode Weekly Contest 3 to 6, 251 distinct prime factors of product of array. And the question statement given is given an array of positive integer nums, return the number of distinct prime factors in the product of the elements of nums. So basically what they have said is that you have been given some nums array right here, and all you have to do is multiply each and every one of them, and after that you just have to prime factorize it and just see how many distinct factors are you getting out of it. So let's just say our numbers are something like 11 and 2. So what you can do is you can just multiply each and every number and you'll be getting 22. After that, what are the prime factors of 22? So we'll be doing the pretty basic math right here. So this will give you 11 and 11. So the number of prime factors, distinct prime factors here are 2 itself. Fine. So 2 and 11, and the count is 2. So that is what you'll be returning. Now also you could be getting some prime factors and also some factors which are not prime. Let's just say you have gotten some integer 6 after multiplying the values of the nums array. Fine. So you could get what? You could get this. Let's just say get as 16. Fine. To make it a bit more clear. So you'll be getting 8 here. After that, you can get 4 and so on up till here. So you see, there are multiple occurrences of 2. You will be taking just one of it, fine, as they have said distinct. Now let's just say there is some number whose factors are coming out to be, let's just say 2, 4, 11. Let's just say these are the factors for now, fine. Now you see 4 is not a prime factor. Why? Because 4 is not a prime number. That is why we just cancel it out. And 2 and 11 are the ones. So we'll be taking only the prime factors out of it. Fine. Now how to do it? We can just apply brute force here. And how do we do it? We can just iterate for each number, that is 2, 4, 3, 7, 10, and 6, and try to find out each of the factors that is present there, their prime factors. That means let's just say you have been getting 2, 4, 3, 7, 10, and 6. Let's just say you're getting 10 again. Now is there any uh, chance you'll be getting some new factor from this 10 and from this 10? Of this 10, obviously not, right? Because both are the same number. You just calculate it for once, you can just leave it for the other tens, right? That is not necessary because the repetitions will give you the same prime factors as the previous ones did give you, right? So there's no need for just calculating a prime factor of a number which has occurred multiple times again and again, right? So we can just store everything in a set or a map so that it is uh, just in a distinct manner, so that we have just all the distinct numbers that are present in our array that is given to us. After that, what do? We just check that what are the prime factors of each and every number. You just check what are the prime factors of each and every number, and thus you will be getting your answer accordingly, right? So now let's just move on to the code, because multiplying is actually not necessary. So after you just multiply, let's just say we will be taking 2 and 10 as our numbers right here, fine. 2 and 10 as our number. If you see what are all the prime factors that are present in 2 and 10, you can see for 2 you just get 2, for 10 you'll be getting 2 comma 5, right? This is what you'll be getting. Now if you multiply it, you'll be getting it as 20. The multiplication of these 10 and 20, 10 and 2 is 20. Now what are the factors of 20? You can see factors of 20 are 2, 10, this thing right here, after that 5, and this is again 5. Now as you see, the prime factors are 2 and 5 itself, and again you're getting the same thing. So either way you'll be getting the same thing. So if you just do it individually, you can still get the same answer. You don't even need to multiply anything right here, fine. So that is the main thing here, because if you just try to multiply everything up, you'll see you'll be getting a signed integer overflow, because nums of I can go as high as 1000. That means if there are 10 to the power 4 into 1000 numbers, then it will actually cause an overflow, obviously. So that is not a good approach to take it. Now we'll be coming on to the correct approach. as we discussed earlier, we just make sure that you insert all the distinct integer and try to map it out. And you can also use a set. I've just used a map here. After that, what are we doing? I have just made sure that I've created another set right here. By the way, there are many other ways you can implement this. This is how I did particularly, and but there can be obviously many other simpler ways too. Fine. Now, what my way says is that you just store everything. Let's just say you have everything in your array. You have it 2 and 10. This is your array. Fine. You stored it into a map, everything. Let's just say this is our map right now. Fine. Now, what I'm doing is I'm going through all the elements of my map and I'm saying if it is divisible by 2, if the number is divisible by 2, let's just say our number is something like 64, right? Now, we know this is a power of 2, and a power of 2 can never have something as a prime factor other than 2 itself. Fine. So 2 is here. So if a number is divisible by 2, right? If a number is divisible by 2, let's just say 8, or something like, let's just say a 12. That will be a better example. If a number is uh, divisible by 2, that is 12. So we know one prime factor could be 2 itself. So we have taken care of that. After that, what do we know? All the prime factors that are there could be odd only. Fine. Now, these odd prime factors could be actually prime also and not prime also. Why so? Because see, 3, 7 and 9, I'll be just iterating on all the odd factors right here. All the odd factors, 3, 5, 7 and 9. Mind you, these things are prime, which is perfectly fine. But now you see that 9 is not prime again, right? Now we cannot check for 9. We cannot say that okay, 9 will be my prime factor. So that is why you just need to do a prime check also here. So I did a prime check and I made sure that if that number is divisible and is also prime, I just insert it into my set. This is what I've done, and at the end of the day we just return the size of the set. That is what they have said. You just need to return the number of distinct prime factors right there. Okay, and this is a pretty basic prime check that I've written here. It is very simple, and I'll just reiterate whatever we have done again. So you just have to make sure that all the distinct integers are put into a set together. After you have put them together, you just make sure for every number you just check, is it a factor of 2? If it is a factor of 2, you just put 2 inside your set once, because 2 is a prime factor. And after you have done that, you just go for all the odd factors, that is 3, 5, 7, 9, 11. You just check for all of these and you check that if the number is divisible by my number that is present in my set or my map, you just check if this number is also prime. You just put it inside your set saying that okay, this is a prime factor of my number which I am wanting to check, and you will be getting your answer. Fine. So this is the whole code, and the link will obviously be in description, and I've also submitted it, so no need to worry about that part. And yeah, if you did understand the explanation, please like and subscribe, and yeah, thank you.